We had industrial 3D specialists taken care of, like a racehorse, a groom, a jockey, a stable. I don't know if any of you go to the jockey club. It is extremely hard to get into the stables at the jockey club if you're a bettor. You have to be an owner. Same thing with 3D printing. It was elite printing, and it was limited to certain experts only. Very focused on rapid prototyping for production, not for play, curiosity, exploration, no thanks. Every iota of the machine was accounted for. Our particular printer had a cartridge, like a proprietary photocopier, that counted the amount of filament that was dispensed, and the filament was extremely expensive. It had a little chip in there that counted stuff. So nobody was allowed near that machine except for the operator. Now, to me, this sounds and feels very much like mainframe culture. Mainframe culture was not responsible for the PC revolution. Mainframe culture, in fact, was the enemy of the PC revolution. So how do you innovate with such a very, very small user base? Then we have the introduction of what I call the rabble of 3D printing. And these are the people who challenge the status quo. No, we don't need to have very large and expensive 3D printers. It's okay to just get something up and running. This is Adrian Boyer's heritage to us through the RepRap initiative. However, the culture that surrounded the initial generations of 3D printers was mainly limited to geeks. A lot of resources were devoted to simply getting and keeping the machines up and running. So technical expertise was still required. And geeks play a lot with the machines, but they don't necessarily have the inclination, the psychology, the skills to bring other people up to speed. They may not have the teacher gene in them. Lots of filament availability now, it's cheap, but the relevance of how we deploy that filament seems to me to still be rather weak. To me, this sounds like open source culture, something that I was very involved with in the early 1990s when I was doing my first degree in systems engineering. I did a specialization in operating systems and database design. So I was communicating with Linus Torvalds directly in 1991-92 when he was asking for help to build the Linux code. There's two leading lights, in my opinion, in the open source movement. So what I'm going to do now is I'm going to draw a parallel between the 3D printing revolution and the open source revolution, which is running on most of your phones. So if you're running iOS or you're running Android, you are running a flavor of Unix. Both of them were created through open source collaborative communities. iOS is based upon Berkeley Systems Division Unix, and Android is based upon Linux. For those of you who don't know about BSD, the fellow you want to look up is Bill Joy. Very nice fellow. So in the early 1990s, Linus Torvalds put out an open call on something called Usenet. There was no internet back then. To get help developing a Unix lookalike kernel wrapped with the GNU tools that somebody else had written over almost 15 or 20 years. So I helped out with that effort. So you could think of, for those of you who've read the book Tipping Point by Malcolm Gladwell, he talks about moments in history where everything comes together and there is a disruption or a sea change in the way we behave as a people. Richard Stallman worked at the Artificial Intelligence Lab of MIT for many, many years. I went down and worked with him when I was doing my undergraduate degree. His mandate was to put a Unix-like system together without corporate backing. Prior to Richard Stallman's work, Unix was the property of a corporation called AT&T, and they had a system called System 5, and you had to pay for a license. In certain cases, the license was very inexpensive if you were a school. In other cases, it was very expensive. Richard's point was software should be free. That was his point. Software should be for the benefit of everybody. Because he looked at the economics of software. It's very expensive to write a program. It's not expensive to copy it. It's not expensive to give it away. Today, the distribution cost for software is practically zero. So the economies within software are very, very strange. Not something we're used to in a material world. Richard's insight was the diffusion of innovation is the answer. It's not okay, in his eyes, to have an innovation and guard it jealously and have a per unit pricing model. Now, he was working at MIT. He got a MacArthur Genius Grant. He got $1 million for being a smart guy. So Richard could afford to be generous with his mind. He was actually asked to be generous with his mind. But I think that his heritage to us, which is very old, still echoes through the communities we're building, although the new generation may not even recognize this man's name. So coming in at just the right time, Linus Torvalds decided he was going to build an open source kernel, which is the, you could call it, supervisor function in a computer that helps to orchestrate all of the subordinate processes and threads that give us the desktop applications, processing, and so forth. This infuriated Richard Stallman. He had been putting off the development of his own kernel while building all of the tools that you need to write a kernel. I'm not going to get into the specifics, details. It's extremely difficult to create a computing operating system from scratch. It takes about 1 million man-hours. Linus came in at 11:59 and wrote a little kernel that really wasn't all that good, but leveraged the dark matter that Richard Stallman had created and got a lot of glory for doing that. These two have kind of reconciled over the years, although Richard will never relent on the fact that he says he wrote Unix. Linus wrote that kernel. Be that as it may, these two men, one of them not very nice, not very friendly, but a genius, and we put together a tremendous amount of the hard work necessary to bring something to fruition, and a very charming and nice man who was able to coordinate and attract, crowdsource, if you will, masses of people he had never met to pursue a common goal. These two men together created something that revolutionized the world. The message for us in 3D printing is that this is possible. If you can do it once, you can do it twice. If you can do it twice, you can do it consistently, if you have focus. So the point of inflection for Linux, which was a hobbyist toy, very similar to where 3D printing is today, was the introduction of the internet. It changed things. It was one of the first internet projects, large scale, crossing over from being a Usenet project to being an internet project. Why did Linux have a chance? Because IBM and Microsoft, and you may not know this, but Microsoft is very much a child of IBM. We're blind to anonymous, unauthenticated transactions between people on a global network. This is not how IBM operates. I'm an ex-IBM and Microsoft employee. I can tell you that identity, authentication, and control are the things that these companies live and breathe. Quite rightly so, it's how they make their money. Because they count. They count licenses. That's how it works. They count computing time. But this left a gap. On a flat rate global network like the internet, where you buy a modem, fixed cost, you get a phone line, fixed cost, you connect to the internet, and off you go. You have basically an unlimited amount of access. And there's no need to authenticate other than to authenticate your connection with your ISP. Creates a huge opportunity. Microsoft and IBM have no means of taking advantage of this because, as we know, strategy informs structure. The structure of IBM and Microsoft. What's that mean? Oh, okay. The strategy and structure of Microsoft are based around authentication. I guess I'll just move ahead. So here's the challenge I have for the 3D printer people out there. I'd like us to stop thinking about our 3D printing activities in terms of these objects and start thinking about them in terms of these objects. I'd like you to bring people into your 3D printing efforts. The other objects are just for calibration of your printer. The next thing is to reach out into global communities and do something with your printer that enables you to grow as a person and to help other people. Now, I mentioned earlier that I was going to talk about my own personal initiative for doing this. The killer app for 3D printing, in my opinion, is young people. Is people. We still haven't discovered the application, so we must enable the population that will discover the application for us. Tiny Boy, in my opinion, is focused on youth. Youth is people aged 16 to 24. My own personal effort is focused on children who are 6 to 15 or so. I'm working with my co-instructor, Mark Roger Yu, to introduce a short course in the summer for Hong Kongers for talented children to come and learn about how to be an inventor. Now, part of this, as I mentioned, the short summer program, we blend creativity, leadership, and independence so children can confidently apply innovation, which is the act of invention. 50% of the time, our students will be in nature on Lantau Island, so they can decompress and deprogram themselves from their urban habits and open their minds. 50% of the time, they will do facilitated making, one of which is building a 3D printer. In August 2015, we intend to deliver the first session. Delivery, as I mentioned, will be on Lantau Island. I'll most likely work with the YMCA. They have a camp in the school close by. We're going to limit to 15 children. We're looking for talented children between the ages 8 and 10. The program duration will be 1 week or 2 weekends. 1 or 2 weekends plus 5 days. And the cost will depend on our feedback from the parents. There will be 3 facilitators, and the languages of instruction will be English, Cantonese, and Putonghua. So, thank you very much for coming today. I think we can enable, in my part, for very early stage innovation, I think I'd like to try to enable the kids. If you can help me, I'd be very grateful for your help. And if you'd like to visit the Inventor Academy, here is the QR code. You can look at it with your phone and perhaps engage in dialogue and help me help the kids, because I'm not quite sure I have the right formula yet. But I am certain together we can arrive at the right formula. Thank you.